Imagine standing in the tall grass of the savanna 200,000 years ago. The sun sets, the temperature drops, and the shadows begin to move. You are sharing the darkness with predators 25% larger than any lion alive today. The saber-toothed cat used immense, heavily muscled forearms to pin giant bison to the earth before delivering a lethal neck bite. Beside it walked the short-faced bear, a colossal omnivore standing 12 feet tall, easily dominating the landscape through sheer physical mass. Against this, early humans brought almost nothing to the fight. We had no claws to pierce hide. Our teeth were flat and blunt, useless for tearing flesh. We were highly visible bipedal targets, lacking the explosive, fast-twitch muscle fibers that allow a chimpanzee to scale a tree in seconds. For decades, science assumed that when these early humans died, they were ambushed on the ground by big cats. When the Taung Child skull was discovered in South Africa in 1924, researchers spent a century believing a leopard had dragged the youth away. But in 2006, forensic analysis of the bone floors inside the child's eye sockets revealed tiny, precise punctures. The child wasn't ambushed in the grass. It was snatched from above by an eagle. We were bite-sized, aerial prey. For millions of years, the human lineage occupied the very bottom of the food chain. By every rule of ecology, a slow, weak, defenseless primate should have been hunted out of existence. Around 1.8 million years ago, early Homo erectus began interacting with the environment in a new way. They captured natural flames from savanna wildfires and brought them deep inside caves like Wonderwerk in South Africa. A simple campfire created a protective circle of light that held back nocturnal pack predators like the cave hyena, an animal equipped with bone-crushing jaws that terrorized the night. This animated diagram illustrates how energy flows through the body based on diet. Eating raw meat requires a massive amount of internal energy just to break down tough fibers. Cooking pre-digested food outside the body, redirecting that energy away from the gut. Those newly accessible calories provided the exact fuel source required to power the evolution of a highly demanding, massive human brain. Stealing fire allowed our ancestors to effectively outsource their digestion to the environment. They traded physical gut size for cognitive expansion, buying themselves the safety and time needed to think. Even with a growing brain, humans remained terrible sprinters. A big cat can accelerate to 30 miles an hour in seconds, and even a chimpanzee easily outpaces us in a short dash. Our biological answer to this deficit was the evolution of naked skin, packed with millions of eccrine sweat glands. This chart tracks core body temperature during exertion. Because we sweat, evaporative cooling keeps our temperature completely stable on a long run. A furry animal lacks this system. As they move, their internal heat climbs steadily into the red zone. Our ancestors capitalized on this biological difference through persistence hunting. By tracking an animal at a steady jog under the midday sun, they forced it to keep running until its internal cooling system failed entirely, and it collapsed from heatstroke. Humans traded explosive speed for relentless stamina. Slowness and sweat became a biological mechanism to run prey to death. Endurance and fire kept individuals alive, but the trait that ensured the survival of the entire species was completely abstract, a radical capacity for empathy. In the Republic of Georgia, archaeologists unearthed a 1.8 million-year-old hominin skull. The jawbone had lost all of its teeth, healed over completely, and belonged to an individual who lived for years after that loss. In the wild, an animal that cannot chew its own food dies of starvation in a matter of days. In Iraq's Shanidar cave, researchers found the remains of a Neanderthal who reached old age despite being blind in one eye, missing part of an arm, and suffering from crippling arthritis. These individuals survived because their family members actively pre-chewed their food and refused to leave them behind. Empathy became an evolutionary strategy. A tribe's resilience no longer depended on the physical strength of a single hunter, but on the collective care network that sustained every single member of the group. This transition from individual instinct to group care shifted our evolutionary trajectory. To sustain a tribe that refused to leave vulnerable members behind, our ancestors had to develop more complex ways to communicate, plan, and divide labor. The tipping point arrived around 200,000 years ago. With the invention of aerodynamic throwing weapons like the Schöningen spears, 5 vulnerable primates communicating a plan could act as a lethal, coordinated strike force. As humans migrated out of Africa, the biological hierarchy of the Pleistocene collapsed. The giant short-faced bears, the cave lions, and the saber-tooths all vanished, thoroughly outcompeted for resources on a global scale. We were no longer hiding in the tall grass, terrified of the shadows. We were actively stepping into the dark. Evolution equipped other predators with fangs, claws, and explosive speed. Our lineage survived because biological weakness forced us to build, adapt, and rely on one another. To see how this cooperative strategy allowed our ancestors to outlast our sister species, the Neanderthals, click on the video on your screen right now.